Alright guys, here's going to be the solutions to this using the unit circle worksheet and practice. These first ones here, we're getting exact values. Okay, let me walk through the setup on that. There's a lot of patterns here. And again, with these, you should really be doing these without a calculator. I don't want some decimal from a calculator. I need you to know exact values and how to find them. And one way we talked about it when we first did it was with the special triangles. And if you remember the side lengths, and then you can do SOHCAHTOA and all that stuff. But now that we know this unit circle and we've seen it, there's a little bit of another option I want to just kind of remind you. So going back to the questions on the handout, the 30 degrees, if you want to check your work, the sine of 30 was 1/2. The cosine was the root 3 over 2. Okay, we'll talk about the tangents in a second. The 60, so the sine is the root 3 over 2. The cosine is the 1/2. So that's kind of a nice one. Okay, and then we talked about on the other video how to find the tangents. To do tangents, you're going to do, if you go to the last video, to get the tangent. So I know for 45, it's root 2 over 2 divided by itself. So the root 2 over 2 divided by itself is going to get you 1. And if you do the other ones, the sine of 30 is going to end up being root 3 over 3 once you simplify. I'm sorry, the tangent, and the tangent for the 60s is going to be the square root of 3. Okay, so check the other video. I walked through the multiplying by the reciprocal and all that stuff. All right, so let's figure out how do we use this stuff. Okay, so first off, we need the sine of 3 pi over 4. So first thing, most of you guys are probably going to feel more comfortable using degrees. So let's stick the 180 in for the pi and simplify. So 3 times the 180 over 4 should be 135 degrees. Okay, so we're going to kind of get an idea of where that is. 135 degrees. If we start in standard position, it's going to end up being in the second quadrant. There's 135 degrees. Okay, now we need the sine of that angle. So what we need to do is figure out which or where would the right triangle be the reference right triangle. Okay, and if you remember with the reference angle, you always use the terminal side, and if you're in the second quadrant, you always come straight down to the x-axis. Okay, that's going to be our reference right triangle. So our reference angle will be that little angle right there in the corner, and it's actually just always in the second quadrant, how far from 180 are you? So 180 minus the 135, we were 45 degrees away. Okay, so that's going to be our reference angle. Okay, and that's going to say, all right, it's going to let us use the 45 degree coordinate up here. So I'm going to know the coordinates right here are the same as the 45 degree angle. Okay, so they're both root 2 over 2, but you just got to think about this angle's in the second quadrant. X coordinates there, X coordinates are negative, but Y coordinates are positive. Okay, so the sine of 3 pi over 4 is just the Y coordinate there, which is just the root 2 over 2. Okay, let's set up the next one. Cosine of 120, same setup. Let's think about where is 120 degrees, what is its reference angle and all that good stuff. So we start there. 120 I know is going to end up about here. Okay, and it's the same reference triangle as the last one because it's a second quadrant angle. It's right here. And if that was 120 degrees, the reference angle would be right there. Okay, and how short of 180 were we? We are 60 degrees. Okay, so the reference angle is 60. Okay, and we need the cosine of it. Okay, so what you can do, again, the x-coordinate is negative. Okay, but it's the same coordinates. The y-coordinate's root 3 over 2, right? The x-coordinate is negative this time, 1/2. Notice. Okay, and it's just a matter of thinking about which one was it asking for. It wants the cosine, right? Cosine is adjacent, which is the x value. So the x-coordinate, the final answer here should be negative 1/2. Okay, let's do a couple others. We get the tangent of negative 30. Okay, so if we sketch the angle, all right, negative 30 now. Instead of going up through quadrant 1, we're going to go 30 degrees this way, right? So there's the angle. Now the reference triangle in quadrant 4 just gets you back to 360 like that. Okay, here's your right angle. That angle is 30 degrees. Okay, we don't worry about the negative when we're doing reference. Okay, it's that measure. It's 30 degrees. Okay, so let's think about on the unit circle, the coordinates for 30 degrees. Okay, and another way to think about it, where would the other two angles would be? If that was the 30, the 45 would be farther down. The 60 would even be farther down, right? So the 30-degree one, if that coordinate there is 1, 0, as we move downward, remember the y coordinates, they're both over 2. The y coordinate's going to be the -1. The x coordinate's going to be the √3. Okay, and again, okay, so now that we need the tangent, though, tangent is y over x because it's opposite over adjacent. So the y value over the x value, okay, we're going to have to multiply by the reciprocal because we're dividing by a fraction. Okay, so I multiply by the reciprocal of the denominator. The 2 divided by 2 will cancel. Okay, we're going to be left with -1 over √3. Okay, which we can rationalize. Don't leave a square root in the bottom, so times top and bottom by √3. And we're going to get -√3 on top, and then square root of 9 on the bottom, or 3. Okay, so we're going to get -√3 over 3. And notice, that's the same thing. That was the tangent. That reference angle was 30, right? Okay, that √3 over 3 is the tangent of 30. We just had to make it negative again because the quadrant we were in, we had the y value was negative, but the x was positive. So it was one of each. All right, and last one, we need the sine of 4 pi over 3. Okay, so again, another radian angle. Let's convert that. Degrees are going to be much more comfortable for pretty much everybody. If we put the 180 in for the pi. Okay, let's see. One way to kind of reduce these two is think about 180 over 3 is 60, right? So we have 4 60s. So this angle is 240 degrees. Okay, so 240, right? 240 is going to end up in the third quadrant. Okay, if that's 240, how far past 180 did we go? Because our reference triangle in the third quadrant, again, is going to be this guy right here. Okay, and this little angle tucked up there by the origin is going to be the reference. So how far past 180 is 240? It's 60 past, right? So the reference angle is 60 degrees. Okay, so let's start thinking about, and I'm even just draw this from memory here. 30, 45, 60. What are the coordinates on a 60 again? Okay, I know the y coordinates. This one's up 1, 2, 3 in the y. It's over 1 in the x. So there's the coordinates for 60 degrees. So we have the same coordinates, except in quadrant 3, what is true? What's true about the x and y values of a point in quadrant 3? They're both negative, right? So x is -½ y is -√3 over 2. And this question was asking us about the sine of the angle. So the sine is just the y coordinate, so -√3 over 2. What I need you guys to do, what you're going to want to do, is make sure that you know this first quadrant on here. Okay, so there's 3 angles, right? You have a 30-degree angle. Okay, you have a 45-degree angle, and you have a 60-degree angle. Okay, and just by knowing the coordinates of the points around the circle, you are going to know the sine and the cosine of each of those angles. Okay, because the way it's set up on the unit circle, we'll do the, let's do the 30-degree angle. If you imagine if you had a triangle here, okay, and let's just say the 30-degree angle is right there. Okay, here's your right angle, and you could draw a similar one for the 45. You know, you could just drop a, this straight down here and get the right triangle with the 45 and so on. Let's see if we can get the coordinates, okay, and let's get those filled in, and then we'll talk about what they mean. And what I was suggesting was, again, knowing that every single one of them was something over 2, okay, so that's going to be a common thing. Let's get coordinates here and here. The 0-degree angle and the 90-degree angle as well. So the 0-degree angle right on the x-axis here, again, the whole idea is that if the radius of the circle is 1, then that distance from the origin is always going to be 1. So that coordinate would be 1, 0. Okay, and up here, if this is the y-axis and this is the x-axis, if you're 1 unit above the origin, the coordinates are 0, 1. Okay, so that is the cosine and the sine of a 0-degree angle down here. That's the cosine of 0. This is the sine of 0 degrees, and so on. Then it's just a matter of this counting pattern. And I usually just think about the y values first because it's easier to think about as you're moving up, as you plot points, as the higher they get, the y coordinates get bigger, right? So these y coordinates go from starting at 0 up to 1 over 2, root 2 over 2, and root 3 over 2. Okay, and for the x coordinates is 0 up here, and as you move to the right, as you go to the right on the graph, the x coordinates increase. Okay, it's the same pattern, 1, root 2, root 3. Okay, so what we now have, if you remember the, let's see, the x coordinate is always going to be the adjacent side, okay, because that's always like the horizontal distance from this angle, and the y coordinate is going to end up matching up with the opposite side, and the whole key is that the hypotenuse of all of these is 1, because it's a unit circle, so that makes the sine of the angle just be the y coordinate because it's the opposite side, okay, which is the y value over the hypotenuse, which is 1. Okay. Likewise, the x coordinate will always be the cosine of the angle. Okay, so it's always going to be that way. The cosine of the angle is always the x coordinate. The sine of any angle on the unit circle will always be the y coordinate. Okay, so you can check these answers, and let me just fill them in for you. But that's kind of the way to set it up. And I mean, I would even take 30 seconds and draw this on your paper. You know what I mean? That can help quite a bit. Right, the 60 was the ones up here. So the sine is the root 3 over 2. The cosine is the 1/2. Okay. The easiest ones, the 45-degree angle, they're both the same. They're both root 2 over 2. Back to here, tangent is opposite over adjacent, right? So tangent, opposite over adjacent. The opposite side is the y coordinate. The adjacent side is the x coordinate. Okay, so if you know these coordinates, you can do a little division, which involves multiplying by a fraction, let's say, imagine we're going back here, right? If you have this drawn out and you understand this concept, you're just going to go and look at the coordinates of a 60-degree angle, okay, right here, right? Okay, because I know my coordinates are going to be the same, except they're the same as the 60, except with the x value is negative. Back to your 30-degree angle right here, right? I just made the y value negative because of the quadrant we were in. So again, make sure we're real comfortable with this page. You know, this video really sets up everything. Then it's just a matter of placing your given angle into the correct quadrant and finding which reference angle it is. And you'll notice these are the only answers we're getting. It's either going to be a half, or root 2 over 2, or root 3 over 2, that kind of thing for all the sines and cosines. Okay, if you get something different, then something's up. Okay, or it could be a 0 or 1 like these, right? Okay, so one other two type of problem, using the same concept. Okay, but we're just kind of working backwards a little bit. Solving an equation saying the sine of some angle equals -1/2. Okay, so let's think about how that works. So I would suggest again, let's draw the first quadrant, 30, 45, 60, and let's just get those coordinates in again. See if you can do this on your own without watching me. You just really need to have this pattern down. There's no way around it. Sorry, those in the middle one there. Let me rewrite those a little nicer. Okay, so I cleaned those up. So, all right, so we have our cosine and our sine for the 30-degree angle, 45, and 60, right? Okay. So if you see something like the sine of some angle equals -half, okay? So first off, let's think about which angle, in the first quadrant, none of them are negative, right? But what would be the reference angle? Which angle has a sine that equals half? Okay. Well, that's the 30-degree angle, right? Okay, so right here, so the 30-degree angle is going to be our reference angle. Okay, so, but that's not our final answer, because the sine of 30 is +half, right? So if we think about where is sine negative, okay, and if you remember, sine is the the y coordinate, right? Sine is always the y coordinate, because that's the opposite side. Cosine is always the x. So in which quadrant or quadrants are y coordinates negative? Okay, so if we think about all 4 quadrants, right, y coordinates are negative down in quadrant 3 and quadrant 4. Okay, so we're going to get 2 answers, one in each quadrant. Now we need to think about what's the angle measure. Okay, the reference angle is 30 degrees. So if we were to place a 30-degree reference angle, meaning right there, what would the actual angle be? Okay, well, we can see that in quadrant 3, we are 30 degrees past 180. So one answer would be 30 plus 180 is 210 degrees. Okay, but also, a reference angle in quadrant 4 of 30 degrees would be like that, right? That angle is 30 degrees short of 360. So the other possible answer, 330 degrees. Okay, the sine of both of those angles would equal -half. Okay, so that's kind of the process there. Again, this is like so important. I can't emphasize it enough. Make sure you get that pattern down. Using it can be a little tricky, and there's some little details. So keep working on it, please, and let me know if there are any questions on setting these up. All right.